All right, welcome to the Rotational Dynamics Note-Taking Podcast. One thing you'll know about this chapter is that all of the formulas will be exactly the same as they were when we were talking about linear motion. Now we're just going to be going around in circles, so that's why it's called rotational. And instead of using English letters, we're going to use Greek letters. So what letter in math class do you use to denote an angle? Theta, very good. It's usually written as a circle with a line through it, and it's called theta. Now, when you get to college, especially in your engineering classes, your professor will call it theta, and you find the hypotenuse of theta. And I always thought something like potato chips or something. I didn't know what they were saying the first 3 weeks of engineering school, so I'm sure you'll get used to it. Now, for angular velocity, instead of using a v, what we're going to use is a omega, which looks like a little cursive W or a but. You said but. No, but. And then we're going to call this omega. Now you might be used to omega looking like a big horseshoe. That's capital omega. All right, and then finally for angular acceleration, instead of using an A, what do we use in Greek? Alpha. Very good. This is alpha, otherwise known as Jesus fish. Okay, the next thing I need you to do is change the word radius in number 4. We're going to change, We're going to change this to the word radian. And make that a radian. And a radian is the same thing as a radius. So in the blank, I want you to put the word radius. I can learn how to spell it. That's radius. Now, where does a radius go from and to? The center of the circle to the outside of the circle, right? That's a radius. So let's just say that radius was 2 meters. A radian is the same length. It's just where? Not in the circle. It's on the circle. So if this was 2 meters, that would be a radian. This is a radius. This is a radian. So in our formulas, R just doesn't stand for radius, it also stands for radian. So how many degrees are in a circle for number 5? 360, so most of the stuff you already know. And you should be working on this with Mr. Henderson right now. So, And Dillman, good, because I've sort of worked out with them that where we would be hitting the stuff at the same time, so you can apply it to both places. How many radians are in a circle? Okay, let's talk about how you're going to remember that. If I ask you the formula for the circumference of a circle, that's not pi r squared, that's the area. What's the formula for the circumference of a circle? 2 pi r, right? But I just told you that r doesn't just stand for radius, it also stands for radians. So the answer to this is 2 pi radians. So the r in the formula stands for radians. Same thing. Now what we're going to do is this. I'm going to give you 3 circles. And I'm going to go ahead and pause it real quick, and then we'll come back to that. So right now on the podcast, you're not seeing this. I'm giving the classes 3 wooden circles, and they're going to measure the circumference and diameter of those wooden circles. So everybody, what I wanted to show you here on the big circle, the medium circle, the little circle, whenever you take the circumference of that circle, we measured that, we divide it by the diameter, you always get a number that's very close to pi. If it was a perfect circle, if I was able to cut those perfectly with my saw, I would get 3.14 every time. Am I cool with that? So what's the formula for pi? Circumference divided by diameter. So that's what I want you to put right in here then. On number 7, the formula for pi is circumference divided by diameter. That's C divided by D. On this next part, it's simply going to be the old conversion factors. Remember when we had to cancel stuff out and change meters to miles and seconds to hours? We're going to do the same thing, and we're just going to use radians now. So it says how many radians are in 550 degrees. The first step we always did was write down the given number. So what was the given number?
550.
550, very good. So I'm going to write down 550 degrees right here. I'm talking this loud, it has to get annoying. Now, we need to get the degrees to cancel out, so where are we going to put it, Mark? On the bottom. And what am I trying to get to, Rachel Barrios? Radians, good job. You are so fast. Now, if you look at the circle, how many degrees are in the circle, Sarah? 360. So I'm going to put 360 on the bottom. That's one circle. How many radians, Joey, were in a circle? 2 pi. Very good. And I'll give you 1 point for anybody can, on their calculator can do this math for me on your homework there. Thank you, George. You're so fast. So 550 times 2 times pi divided by 360 gives you about 9 point something. And that is 9 point. Oh. Great job, George and Zach. It's 9.59. Now the degrees canceled out here, and you end up being with radians. Now we're going to do the same thing, but now we're going to use revolutions instead of degrees. So we're going to write down our given number. What's your given number here, Chris? Awesome, 4.35 revolutions. Now we got to get the revolutions to cancel out. So here we're going to put that on the bottom. Great. And we're trying to get to what answer here? For the camera? Exactly. It's radians. Boy, I wish everybody could hear you guys like they hear me. And so how many revolutions are in a circle? Stetson? 1. Very good. 1 revolution in that circle. And then how many radians are in a circle, Kayla? 2 pi. So now what I do is I'm going to take that 4.35, multiply it by 2, and multiply it by 5, and that ends up giving you somewhere around, let's see, that's 8.7 times the 27 something? 27.33. The revolutions canceled out, and I'm left with radians. So once again, we haven't used any formulas yet. This is just conversion facts. Okay? Now I'm going to show you some stuff to do with formulas. Did I screw up? Because I don't really care where you write these notes here, or even if you do. I just want to show you how the formulas are going to be exactly the same. Once again, for distance, what units did we use in when we were talking about straight lines? Meters, right? Well, now we're not using meters anymore. We're using radians. So instead of meters, your units are going to be radians. Instead of a D for distance, what letter are you using?
R.
No. Theta. Okay, it's all Greek. So anytime you see Greek, you know you're going to be going around in a circle in this chapter. For velocity, instead of using V, we're now using omega, that little cursive W. What units did we use for velocity when we talk about linear? Noble? What units do we use for velocity? Meters per second. Good job. Now, instead of using meters per second, what are we going to use, Noble? Radians per second. Very good. So it's the same exact thing. We're just using radians instead of meters. For acceleration, Dan, instead of using A, we now use what? Alpha. What unit do we use for acceleration, Victoria? Well, we used to use meters per second squared. Now we're going to use radians per second squared. Great job. Okay, I want you to look at this next formula here, and we're going to use the same process. It says, what is the angular velocity? So what letter am I looking for if they say, what is the angular velocity? Kelsey, do you have any clue what letter it is? Angular velocity. Omega, very good, that little cursive W. So if you're looking for radians per second of a merry-go-round that spins 1 revolution in 4 seconds. Well, what was the formula that we just wrote down on that other page here for angular velocity? Go to Tessa. Yeah, radians divided by seconds, right? So, I want to show you this. What was the old formula for velocity? No, the old formula. Zach, you remember? It was distance divided by what? Time. Okay? The formulas are going to be exactly the same. You're just going to use Greek letters. So instead of a V, Gary, what are we using instead of V now? So instead of the V, we're going to use the omega. Instead of a D, what are we using? Kelly? Sorry. Close enough. Omega, theta rather. Okay? And a T is going to stay a T. So now what we have to do is we have the formulas are exactly the same as long as you know what Greek letters match up with the English letters. So we're going to plug in the theta now. So let's look at what's given to me. It says 1 revolution. Well, you can't use revolutions in this. Theta has to be in what units? Radians. So how do I get from revolutions to radians? That's right. We're going to change that using that little conversion factor. 1 revolution is 2 pi radians. Then you're going to divide that by the time. Maddie, what time do you have in this problem? 4 seconds. Good job. So now we're going to take 2 pi and divide it by 4. Well, 2 divided by 4 is half. Half of pi gives you about 1.57. The revolutions cancel out, and I'm left with radians per second. So this is angular velocity. Instead of meters per second, it's now radians per second. Let's look at the next problem. It says, what is the angular acceleration? Jessica, what was the old formula for acceleration? Do you have any clue? Very good. It was velocity, change in velocity over change in time. Like this little delta t, or v over delta t. Okay. Well, instead of using an A, Cameron, what Greek letter do you use for angular? Close. For A is alpha. Very good. Now you're right on the next one. Instead of using a V, you now use a omega, and then the t stays the same. So I want you to fill in these letters and let me know what the angular acceleration would be. Okay, so what are we going to plug in here? It says the angular acceleration of a merry-go-round, if it starts from rest, so what did they just give you? Initial velocity, very good. That initial omega is 0. And it reaches an angular velocity of 1.571. What letter is that? 1.571 radians per second. What's that? Very good. It's the final omega. Up there. And it says it does that in 2.75 seconds. So Melanie, what's letter is 2.75 seconds? T. Okay. Now all we do is plug everything in here. So it's final minus initial. So I'm going to take the 1.571 minus 0, and that's radians per second, and divide that by the time of 2.75 seconds. Need a little help on the math on this one. This is a difficult one. Who's talking? Hi, Rachel. 0.571. And what would the units be? Radians per squared. You got it. Good job. Put a +1 on that homework. All right. All right. So the frequency is the number of revolutions per second. So that record player I have on my desk is going around at 33.3 revolutions per minute. I want to know how many revolutions per second. So like George was saying, you're simply going to divide it by 60 so we can get these minutes to cancel out. So 33.3 divided by 60 is about half-ish, so about 0.18. What did I say, 0.18? 0.55? Okay. I don't know. I have no clue where I got that from. And so that gives you revolutions per second. Now, the period is the same thing as the amount of time. I want to know how many seconds per revolution. So, period. We use a capital T for that, for the big capital time. Once again, it's the same thing as the number of seconds per revolution. So if I have 55 revolutions every 1 second, isn't that the same thing as saying 1 second divided by 0.55 revolutions? All I did was flip that. Does everybody see what I did there? Okay, up here, number 12. Frequency is revolutions per second. Period is seconds per revolution. It's flipped. Yay? So look, I just simply flip-flop these numbers. instead of 33.3 divided by 60, I'm taking 60 divided by 33.3. Or you could say, instead of 0.55 revolutions per 1 second, I could take 1 second and divide it by 0.55 revolutions. And when you do that, now you get about 1.81, and that's seconds per revolution. Now, I like this formula a little bit better. I simply say this, that period, or time, is the inverse, or 1 over the frequency. You could also say that frequency is the flip-flop of the period, or 1 over period. Either one of those work. So if you know 1, just take 1 divided by it, and you got it. So let me show you how this works. If I want to find the period, t, it's the same thing as 1 divided by f. So what is 1 divided by 0.55? It's 1.81. Okay? It ends up being that answer. So that's how I like to do it, is just take that frequency equals 1 over time equals 1 over frequency. You do it either way. On the next one, you're given 7,200 revolutions per minute. To get angular velocity, it's measured in radians per second. So what I'm going to do is I'm going to switch 7,200 revolutions per minute to radians per second. I want you to try that on your own, and then we'll do it together. Okay, so if I want to find out the angular velocity in radians per second, I got revolutions on top, so let's get that on the bottom here so it cancels out. How many radians were in 1 revolution? 2 pi. So 2 pi r is the same thing. R is the same thing as radians. Now I got the revolutions to cancel out. I got to get the minutes to cancel out. They're on the bottom. So Jessica, where are you going to put them? On the top. And how many seconds are in a minute? 60. Now I need some help doing some math here. And 753.6. Oh, look at that. And it's going to be in radians per second. Cool. Okay, we're going to scratch out 15 because you can't do it. I didn't give you enough information. And that is your 18-minute class for rotational dynamics. Love you guys. Hope to see you tomorrow.
Don't say nothing to me, boy. You look like
That's George Bell.